Hi guys, please like, share and subscribe. And if you want full course for any actuarial subject, visit theactuarialguy.com or WhatsApp on this number. Thank you.
In this video, I want to start going over the plot function in R, which is typically used to plot the graph of any variables that we have, right? So let's quickly look at examples of how plot works and how it adapts to uh, different scenarios. So if you would put two numeric vectors into plot, it would automatically directly give you a scatter plot, and then there are other arguments that you need to change into the plot function in order to change the type of plot that you're getting. If you put a data frame directly into it, it will give you a scatter plot matrix, which is something we'll talk about. This is basically multiple scatter plots of uh, different sort of data sets or variables that you have within the data frame, right? So let's say I have a four variables, as I do in iris, four numerical variables, right? So it will just give me the relationship between variable number 1 and 2, 1 and 3, 1 and 4, then 2 and 3, 2 and 4, 2 and 1, so on and so forth, right? So it will just give me the relation, the scatter plots of various combinations of the four variables, right? So that's what it is able to do when you give it a data frame, and I'll show you this, right? Then if you give it a linear model object, I'll show you this as well, although we have not studied linear models yet. We studied this in the CS1 course when we do the chapter on linear regression. So if you give it a linear model, it directly creates diagnostic plots. This is also something I'll show you. And if you give it a factor, it will directly make bar plots, right? So it's a very smart function which adapts to what is the kind of data you're giving it. Now let's start by giving the plot function two very simple vectors. So I've defined x coords, which is just the x coordinates, which is a vector from 1 to 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have defined y coordinates as a vector which has these values 2, 5, 3, 6, 9, 11, 15, 12, 18, 20, right? So this is what you've got. And let's say you plot x coordinate and y coordinate, right? So what will this look like? So first let me just define my x coords and y coords, and then I will just plot these two, right? And by default, since these are two vectors, it should give me a scatter plot, right? So let's see what that looks like. So you just directly get a scatter plot between x and y, where each point is represented as a dot, right? Each combination of x and y, right? So this is how your basic scatter plot looks. So you would, if you would see against the value of x as 1, you have got y as 2, which is this first value. Then against 2, you have got 5, right? So on and so forth, right? uh, Next, if you can also give the same relationship to a plot in another way, which is this, by using this tilde notation. Here what you're saying is y is a function of x. So you put y on the y coordinate and x on the x coordinate, which is what we told it here as well. So if you see the help on plot, so default scatter plot function. Yeah, so you put x and y. So this is one way to do it. You put your x and y, whatever you want on the x axis and y axis, you put it directly. Or another way to put it is you just use this tilde notation, which is y coords, which is a function of x coords, right? So even if you do this, you will get a very, very similar plot. So both of these are equivalent, right? They're alternatives of each other. Then if you just want to plot one function, you can also do that, and by default that will be taken as the y coordinate, and x coordinate would then just be taken as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is what we had anyway taken it to be. But then R automatically just uses indexes on the x axis. When you just give it one vector, it will just assume that the x axis is just indexes, that is the positions of it, and if you are giving it 10 values, then the position will be 1 to 10, right? So you can also do that. And how do you do that? You just give it plot y coords, and by default x axis is just taken as index, which is 1 to 10, right? So again, the plot looks very similar, but here if the value of x coords would have been something different, not same as these indexes, the graph would have looked different, obviously, right? So that's the first thing. Now how do you you obviously usually would want a prettier plot than this. You would want some sort of legends, you would want to color these dots, so on and so forth, right? And then you might even want a line chart, a bar chart, something like that, right? So how do you draw all of those? Let's talk about that now. So how do you customize your plot? Some of the key parameters are listed here. The first parameter is called as main, which helps you add the title on the top of the plot. Okay. Then you have X labels, which is through which you can customize this label on the x-axis. Then you have Y labels, which is able to add a label on your y-axis. Then you have call, which is able to change the color of your points, or if you're making a line or some other kind of bars, then you can change the color of that as well. Then you have PCH, which is the plotting character, which is the shape of the points. So you have multiple options for the shape of the points. We will also see this. You have type of the plot, and then you have various types that you can put in here, right? So types can be points, which is what we have been taking by default, right? The circular dots, points that we are getting a dot plot. You can get a line plot, you can get both, which is dots with lines. You can get an over plotted type, which is dots on top of lines. Then you can get histogram like vertical lines, which are H, and if you put type as S, then you get a step plot. So you have all of these options. Let me just show you all of these. Before that, let me just just run this function, okay, which is able to show you how all of them work together. Let me just start with this itself. So here what have we told are, we have told that I want the title of the plot to be sample data over time. X label is time in days, Y label is value in units, then type is B, which is both points and line. I'll show you by changing this. Color is blue. You can obviously change it to anything. So if I make it red, then it just would take red and the whole thing would become red. You have put PCH as 19, which is a solid circular points. Let's try with other values. What do we get here? So if I put PCH as 1, then what will I get? So you're getting circles which are not solid. If you put 2, then you're getting triangles, right? So you can check out all of these. You can also Google and see like what are the different values for these. Okay, you're getting 3 is plus, 4 is crosses, 5 is diamonds, right? So all of these you have various options here in terms of what you want the style of your plot to be. In terms of the dots, what do they look like, the shape, okay? And then you have line width, which is LWD. You can put if you want to get a thicker line, you can obviously increase this. So let me try with 4 and let's see what it looks like. So your line has gotten thicker, right? So you have a bunch of options here. And we've taken the type as B. So if we want to experiment with the different types, let me just quickly show you how that works. So you have various types that we had looked at, and you had P, which was the default one we've already seen. Let's see L. That would just give you a line. These dots would disappear. So yeah, this is just a line, and then PCH is just irrelevant. Then you have B, which is both points and line. We have already seen. Overplotted. You will see this is different from what B was like, right? In case of overplotted, the dots actually appear over the line, right? In case of you get both, where the dots are there, the line is not there, right? Line connects the dots, right? But when you do O, you see that the points are actually above the line, they're on top of the line, right? So you have that. Then you have H, which is histogram like lines, so you'll get straight lines, vertical lines here if you put H, right? So this is what it looks like. And then you have S, which is a step plot, which is also very straightforward in terms of understanding. You just get steps, right? So every change is reflected as a step. Right, so you have these, and yeah, you can just experiment around with these different arguments, right? So that's very straightforward, right? Now let me show you what a plot with a data frame looks like. So you've seen a plot with two vectors, right, or just putting in one vector. Let me show you what it looks like with a data frame. So I'll take a data frame which is just the numeric values from iris. Okay, so what are the numeric values from iris? They are just sepal length, sepal width, petal length, petal width, right? So if I put this in inside a plot, what will I get? Let's see. So as I told you earlier, this would lead to a scatter plot matrix. Okay, see, this is what your scatter plot matrix is. The first row represents sepal length, second is sepal width, the third one is petal length and petal width. So this is a scatter plot between sepal length and sepal width. Okay, then this is a scatter plot between sepal length and petal length. And then last one is a scatter plot between sepal length and petal length. Okay, so you see row and column, which one is represented, right? So you have all of these scatter plots, right, between four variables when you put the data frame into your plot function. So it's a very smart function that way. When you put in a factor, what would be a factor? Let's see. So if you see the categories in iris, the different species, that is a factor. It can only take three values, which is setosa, versicolor and virginica. So I'll put this into my variable, which is the categories, and then I will plot this, and you will see it will lead to, it should lead to, and we had read about this, bar plot, right? So it will just show the relative ratio of these three species that you have. And let me do that. So that will be plot of categories, right? And you see you have the three categories. In case of this iris categories, you have 50 values of each one of them. So it just looks like a bar with bar chart with equal bars, right? So that is what you have here. So that's something we have seen. Yeah, and you can play around with the other parameters here as well. So if I plot categories and I tell R that the color needs to be light blue, the Y label is frequency, and the main label, the title is color of iris, count of iris species. So you get count of iris species, and then it's a light blue bar, and you have all the species name written, and on the Y axis the label is frequency, right? So you can also do that. Now this was in terms of creating plots. What if you want to add something to an existing plot? Now what could you be adding? You could be adding one additional point to a plot. You could be adding new lines to the plot, right? You could be adding some sort of text in the labels. You could be adding a legend, which basically tells you which axis represents what. You could be adding an AB line, which is which just adds a straight line horizontal to 0, right? If I put AB line H is equal to 0, so it's just a straight horizontal line at 0. Let me do this. So if I do AB line H is equal to 0, so what does this do? This just added a line here. So if I put AB line H is equal to 3, it will put a line higher up, right? So you can add a line like this, right? You can also use AB line to add a regression line. For that, you use the linear model library. So you add AB line with linear model, y being regressed on x. So y is your dependent variable, x is your independent variable. So you take this regression, you're fitting this linear model, and then you're adding AB line, which would just add a regression line. So we can actually do that with your x coords, y coords data. Okay. How will we do that? Firstly, we just plot your x coords, y coords data. So let me do that. So I'm just plotting this data, and I'm titling it as data with regression line, but the regression line has not come in yet. In order to add this regression line, I'll just use AB line. Okay, but within AB line, I've told it that the line should be red. Then I'll put LTY as 2, which is your line type argument. So 2 is a dotted line. You can actually Google and see what are the various values for LTY. So you have 1 is solid, 2 is dashed, then 3 is dotted. So this will be a dashed one. 4 is dot dash, 5 is long dash, 6 is 2 dash. So you can specify this argument, and then I've told AB line, what do I want to plot as a line? I want to plot a linear model, that is a linear regression with y being regressed on x, right? So now if you see, let me just put my plot again. So here's my plot, and then I add this regression line to it. So a dotted line regression line, which is a line of best fit using a least square method by minimizing the square of the distances between these points and this line, has been put here. Of course, you will understand much more about this once you do your linear regression chapter, right? So we'll revisit this in case you're watching this before you've done that, right? Which you most likely are, right? So this is how it works, and then let's look at other stuff. So this is something we saw. And then if you want to add a legend here, right, you can also add a legend, which is on the top left. Let me show you this. On the top left, I'm adding this legend. The legend is called as trend line. The color is red. So I'm trying to represent this regression line. I've again used the line type as 2, and BTY is the number, BTY is n, that is no box around the legend. If I would not put this argument, then there will be a box around the legend. So again, you can seek the help on this legend and see like what the various arguments are. If you just remove this and you run this again, then there will be a box around the legend. Okay, you can seek the help on this, but just trying to show you how you put in a legend. So you can add various elements to the plot after the plot has been made using these AB line and legend kind of functions, and that's how it works. That's all for the plot function in R. Now let's talk about importing and exporting data from R. Okay, now let's talk about importing and exporting data from R. So by default, you know that there are a couple of data sets within R, which we've already looked at. Iris is one of them, right? So you can get these default data sets, and a lot of times exam questions and practice scenarios will ask you to refer to these default data sets. You can do that simply, right, by just calling them. But a lot of times you have to work with custom data, and in real life that would be the case. You would need to import the data into R before doing data analysis on it. Now we talk about two types of data sets which we would be importing into R. One is your comma separated value files, and the second one is your text files. Both of these data structures are very, very similar. The only difference here in context of our conversation is that the comma separated value files are in them each value is separated by a comma, right? So that's how they're stored, and then R reads them as a table. Excel also reads them as a table. And then you have your text files, which use a delimiter other than comma, right? So each data value is separated either by tabs, spaces, or other characters, right? So R can read both of these files. Now, how do you read them? So one way is to just use the RGUI, graphic user interface in RStudio, in order to read these files. So in the environment pane, you can go to import datasets, and then you can choose to import from text base or from text reader, and then you can just select your file. So let's do this. Let me just show you. So we are talking about the environment pane, and we are clicking on import data sets. You can also import from Excel, so you can read XLSX files, but for now let's just stick to from text files, because from an actuarial exam point of view, this is the most important thing. So let's click on from text base, and then let's say I want to read a PBOR file, which is my Part B online resource. Let me open this, and in any of these there would be a lot of files. So I know time series, okay, that's CS2. Data analysis should have some file. Yeah, aids.csv. This file is here. I double click it. Okay, so this is my data. See, it has year and cases. So this is how it would be read, right? And this makes sense. The encoding is automatic. All of these options you don't need to change. The separator it has detected by default, it's comma, right? And decimal is shown as period, right? That is a dot, right? So yeah, and then you just click import. So this data set is imported. Now AIDS data set is available, and you can directly access it. So you can just say call AIDS, and this data set comes up. If you just want to plot it, you can just tell R to plot AIDS, right? And it gets plotted as a dot plot. Against year, I have the number of cases. So very, very straightforward stuff, right? So that's one way to import, and this way you can also import your text files. Let's see if I can find a text file now within the PBOR. Yeah, babyweights.txt. So again, this here, the separator is tab instead of a comma, and again it's able to read on its own. The data frame would end up looking like this. Against gestation of the baby, in terms of months, you have the weights. Okay, so you can directly import. So this data also comes in. Very, very simple to work with. Okay, so this is how you do it. Now you would notice that in order to read these, R has actually run some commands, right? So it has run this baby.weights variable. It has defined this variable as read delim, okay? And then it has given it the path of the file. So it's able to read this, okay? Similarly, earlier for AIDS, it ran this read.csv command. So you can also do the same thing by running these functions read.csv and read.delim, right, in order to import these data sets. You need not do it using the GUI, although the GUI is very, very convenient, but you can also run these commands, right? So if I just clear all of my variables, right, now I don't have any variables, so I can run this command in order to get my data set, right? And then I can call it AIDS, and I can store it here, right? So now AIDS will get defined, right? So AIDS is defined in a very, very similar way. Similarly, baby weights is defined with read.delim, right? Talking about these functions in a bit more detail, you have read.csv, which is something we just ran, right? And then you also have read.table. You have read.delim, which I just showed you. You also have read.table. So this can take a bunch of arguments. You can tell it like whether your data has a header row or not, right? So in our case, both of our data sets had header row. If I would have read it by saying that there's no header row, then this would be read as data itself, right? So what happens if I read baby weights as read.table and I tell it that the separator is a tab, right? Which was the case, yes, because it was a text file, and we checked that the separator is tab. And let's say I put header is equal to false. So the first row will not be read as a header, but it would be read as data. So variable one, the first row is gestation, the first row's first value is gestation, the second value in the first row in the second column is weight, right? So these have been read as data, right? Which is obviously not correct. So we want to tell it that the header is there in our data. So there's a header. So this argument becomes true, right? And that's the right way to do it. Okay. So this is how you read data. And then this is about reading. You can also write data. You can export data to a CSV or to a text file. And for doing that, you can just use write CSV or write table command, right? These functions. So there's a default data set called as empty cars in R. Let me check if it's still there. Yes, it's there. Yeah. So it has a bunch of variables for various car, MPG, CYL, all of so on and so forth, all of these things. So if you want to write this into a CSV, you want to store this on your computer as a CSV, how do you do that? So you run this command, right? Write CSV. You always have to give it row names is equal to false, because by default, each row has an index 1, 2, 3, 4, 5, 6, which would get stored, which you typically wouldn't want. So you would put it as row names as false, and by default this will get stored into your working directory. So what was your working directory command? Yeah, get wd was your working directory command. So it would by default, I'm guessing, get stored in your working directory. So right now it's within our programming lessons CS1R. If I write it, it would just get stored there. So now I have stored this file, and I'll go and check in my user Apple documents R programming lessons CS1R if this file is stored. So within documents, what was it called? R programming lessons. R. Yeah, R programming lessons and CS1R, and you see carsdata.csv has been stored here. So this is how you export your file, right? You can also export as a text file. So in order to do that, you'll have to use a write table function. So write table, and yeah, write table. Let me just get the help on this. So here you can you give the separator, and you can give anything as the separator. So if I just want to give it a text file, and then the separator can be tabs. So how do you do that? So you just give it a separator as tabs. Okay, so this also you can run, and then you see your data has been stored as text, right? So if I open both with Excel, let me show you what the data looks like. So this is your data, and if I open the other one, yeah, similar, right? But this is a text file and it's separated by tabs, but Excel is able to read it. Okay, so this is what you have got. Yeah, that's how you import and export data from R. Thank you.